Now we can see some problems based on rate expression or rate law. And surely that will be related to the order of the reaction. Rate law is related to order of the reaction. And you can see two problems here. The first one is for a reaction A plus B gives product. The rate law is given by R is equal to K into concentration of A raised to 1 by 2, B raised to 2. What is the order of the reaction? Order with respect to A is half. Order with respect to B is 2. And the overall order is half plus 2, 2.5. That is the order of reaction. It is a 2.5 order reaction. Now see the second question. The conversion of molecules X to Y follows second order kinetics. What is the meaning of second order kinetics? Order is 2. The concentration of X is increased to 3 times. How will it affect the rate of formation of Y? The concentration of reactant increased 3 times, you know, surely the rate of the reaction also will increase. But what is the relationship? We can use the rate law expression. Rate is equal to K into concentration of reactant raised to the power equal to order of the reaction, isn't it? So here order of the reaction is 2. So we can write the rate equation as rate R1 is equal to K into concentration of X raised to 2. And after increasing the concentration 3 times, what will be the equation? R2 is equal to K into 3x all raised to 2. 3 times. So concentration 3 times increased. So 3x all raised to 2. Or R2 is equal to K into 3 square into concentration of X square. 3 square, you know, 9. 9 into K into X raised to 2. You compare Kx square is R1, this equation and this equation. Kx square is equal to R1. So we can write it as 9R1. So what happens to the rate of formation of Y? The rate of formation of Y increases 9 times. 9 times increase in the rate of formation of Y. Is it clear? Now integrated rate law, that is the next one. Or integrated rate equations. The first one is zero order reaction. You can take a general equation, R gives P. R represents reactant and P product. So R gives P. How can you represent rate of this reaction? We have two methods. The first one is instantaneous rate. Rate is equal to minus dr by dt. And we have another equation, that is rate expression. Rate is equal to rate constant, K into concentration of R raised to 0. Comparing these two expressions, we can write minus dr by dt is equal to K into R raised to 0. K into concentration of R raised to 0. Now we can take this term R, concentration of R to the same side. So now we can write it as dr by dt is equal to K into dt. But concentration R raised to 0, what is the meaning? 1. So dr is equal to K into dt, or dr by dt is equal to K. Isn't it? Already it has a negative sign, so dr is equal to minus K into dt. So here dr divided by R raised to 0. R raised to 0 is meaningless because R raised to 0 is 1. It's equal to K into dt. minus dr is equal to k into dt, or dr is equal to minus k dt. Now we have to integrate this equation. Integrate. dr on integration gives r, concentration of r. K is a constant, it will not change, but dt on integration gives t plus constant of integration, that is represented as I. So the equation is concentration R is equal to minus kT plus I. I is constant of integration. Now in order to get the expression, at the beginning of the reaction, that when t is equal to 0, at the beginning of the reaction, that means when t is equal to 0, the concentration of R is initial concentration R0. When t is equal to 0, that means beginning. It is the beginning of the reaction. The reaction is not started. It is going to start. That is the beginning. Beginning of the reaction, the concentration of the reactant is initial concentration. Initial concentration is represented as concentration of R0. Concentration of R0. So when t is equal to 0, or at the beginning, we can write R is equal to concentration of R is equal to concentration of R0. So here that one is substituted. Our equation was concentration of R is equal to minus kT plus I. And here the values are substituted. At the beginning, R will change it to R0. Concentration of R0. That is equal to minus k. T is beginning. T is equal to 0. At T is equal to 0. K into 0 is equal to I. Or I is equal to concentration of R0, initial concentration. So what is constant of integration? That is initial constant concentration of R0. Substitute the value in the previous equation. We will get concentration of R is equal to minus kT plus concentration of R0. That means I is replaced by concentration of R0. Now take this minus kT to this side, then R to this side. Then what will be the equation? KT is equal to R0 minus R, or K is equal to R0 minus R by T. So it is the integral rate equation for zero order reaction. Integral rate equation for zero order reaction, K is equal to concentration of R0 minus concentration of R divided by T. It is the plot of concentration of R against time for zero order reaction. It's an important graph, you should understand it properly. As the concentration of R decreases, you can see with the time, as the time proceeds, concentration of R decreases. So at the beginning, 0, what happens? Concentration of R is very high. And you can see a sharp and fast decrease in the concentration of R as the time proceeds. So you will get a straight line graph with a sharp decrease in the concentration. So it represents the graph for a zero order reaction. And concentration R is plotted against time for zero order reaction. It is an example for a zero order reaction, already we mentioned it. Dissociation of gas on metal surface. Dissociation of NH3 on platinum catalyst at 1130 Kelvin, right, is equal to K into concentration of NH3 raised to 0, independent of the concentration of the reactant. Now in the case of first order reaction, we can take the rate expression, rate of a reaction. R gives product. R gives P. Rate can be expressed in two ways. One, instantaneous rate minus dr by dt. Rate is equal to minus dr by dt. Or the rate law, R is equal to K into concentration of R. Combining these two equations, we can write dr by dt minus dr by dt is equal to k into concentration of R. Take the concentration of R to the same side. Dr by R is equal to minus k dt. Now we can integrate this equation, integrating the two sides. It is a form of integration, dr by R. When you integrate this one, you will get ln R, logarithm to the base e, natural logarithm. Ln concentration of R is equal to minus kt, dt on integration gives t, plus constant of integration I. As in the previous case, when t is equal to 0 at the beginning, when t is equal to 0, concentration of R is equal to concentration of R0. Concentration of R is equal to concentration of R0, where R0 is the initial concentration of the reactant. Substitute these values here. Ln R0 is equal to minus k into 0 plus I. Ln R0 is equal to minus k into 0 plus I. Or ln R0 is equal to I. Here what is constant of integration I? Ln R0. Substituting the value of I in the equation, ln R is equal to minus kt plus ln R0. You can take the logarithm terms to the same side. Ln R by R0 is equal to minus k dt, kt minus kt. Ln R by R0 is equal to minus kt. Or k is equal to 1 by T ln concentration R0 by R. Ln R by R0 minus ln R by R0 can be represented as ln R0 by R. That is done here. K is equal to 1 by T ln concentration R0 by R. And we can rewrite this equation as K is equal to 2.303 by T log concentration of R0 by R. Logarithm to the base 10. If you want to convert it into logarithm to the base 10, you have to multiply it with 2.303. So K is equal to 2.303 divided by T ln concentration of R0 divided by R. So here if you want to find out the right constant, you should know the initial concentration and concentration after time t. That means concentration of R0 and concentration of R. Suppose initial concentration is not given. Instead of that, concentration at time t1 and concentration at time t2 are given. In such a case, can you derive an equation to find out rate constant? That is the question. Okay, we can try to find it out. Ln R1, that means at the time T1 concentration is R1. Ln concentration of R1 is equal to minus K T1 plus Ln concentration of R0. At time T2, Ln concentration of R2 is equal to minus KT2 plus Ln concentration of R0. Simply it is substituted in the equation. It is written as ln R0 minus R. Then if it is written as ln R0 minus R, you can rearrange it in this way. Ln R1 is equal to minus KT1 plus ln R0. We got two equations, equation 11 and equation 12. Now subtracting 12 from 11, subtracting 12 from 11, ln R1 minus ln R2 is equal to minus KT1 minus KT2 minus KT2. It is equal to ln R1 by R2 is equal to K into T2 by T2 minus T1, or K is equal to 1 by T2 minus T1 ln R1 by R2, where R1 is the concentration at time T1 and R2 is concentration at time T2. R1 is a particular time and R2 another time. So from this equation, it is possible to find out right constant. Or we can rewrite this equation as K is equal to 2.303 divided by T2 minus T1 into log concentration of R1 divided by concentration of R2. Okay, I think it is enough for today. Next class we can see some problems related to these equations.